So we looked at the first example, the list and file chooser, and also text area. Not going into any details. So list has this selection model called get selection model. You can do a couple of things. You get the selected item property where you can add a listener to listen to the user clicking the different elements of the list, and possibly doing the multi-selection if you have enabled that. So that's through the selection model as well. The selection model you set whether it's single selection or multi-selection. And the content of the list can be defined as this observable array list. And I said the observable word here means that whoever needs to be able to react to changes in that list can register to be a listener, and you can do that, and these components do that so that the list knows to update its graphics when the observable array list changes. In the bottom I have this text area. It's rather simple component, but you just need to display or allow, I think, user to edit multiple line text. Text area is your component, but it doesn't support like a bold font or colors or anything like that. You need to use another component for that. I think I will show that later. I'm not sure yet. And then we have the file chooser. You just create a new file chooser. You set the title, set the initial directory, and then show open dialog or show open multiple dialog depending on the needs of the application. And both the directory and the returned files are these Java IO file objects. As said, I hope you are already familiar with those. If not, you can just follow the example applications to the exercises. I'm not asking much about file operations in my exercises, as they are not the key of the graphical user interfaces. Then I have this minimal table, and in this case I used Java Beans or JavaFX has its own property things. Observable list was here, and this file info was the class of my own written in the end of the file, but still inside that main class. And this getX, if you are using this property things for to define the content, then you must write the get whatever property name you had there. Must match the table columns when you are defining there. So for example, here property value factory. Using this, you give here the name of the property, and then in this case, this file info class, whatever you call your own, it must have similar matching get file name. So here is file name, so here must be get file name. Get appended in front of and the first letter capitalized. And then this last example was a little bit more complex. So this shows that the data model for the table can contain objects of any kind. The table itself can display directly strings and numbers and the common types, but the cell value factory was used here, so it allows you to define how arbitrary classes can be transformed. For example, strings for displaying the table, usually because we convert things to strings for showing in the table. And Slider was also used here, and to listen to value changes in the slider, you get the value property of the slider and add listener there with the self-type change listener, and it's always number because slider just contains numeric values. Listeners are, of course, the heart of this course. Components and listeners are the key things to know, and then the listeners for those lists and tables, listen to the changes into selection, can be created through the selection model, and the selection model tells you what is selected at any moment, so you can get the selected index and from the selection model you can get selected item property and add listener there, which is a change listener. And yeah, you can of course listen to mouse clicks. The user clicks on the table or list, and key events and others. And then when you have this observable list, you can listen to changes on that. So new list change listener, for example, shape modifier, shape info example was not there and unchanged. And yeah, don't leave this question mark extends from these definitions of these functions, because you will get the name collision error there. And models, as I already briefly mentioned, this is word I can hopefully explain at this point if it's not clear yet. So model refers to the data model containing the data that is displayed on a component. And you can listen to these events in the model as was shown. So observable list is a model for both list view and table view. You can register to, as shown in the previous slide, the events, changes in that list, and the table or list, they register to listen to that list, and whenever data changes, they update themselves, and whatever is told them as the way to convert the data from the model into what is displayed in there, they use that. And we saw a couple of different ways to control how the data in the model is converted to the strings, in this case is the strings which are displayed. And the model view controller software architecture is something I want to say you a couple of words about. It's a classic software architecture designed for graphical user interfaces. It's mentioned often when you're looking at the materials for graphical user interface programming. Well, I just go through this slide now so that the model is what was discussed in the previous slide. Data model in there. That's the M of the MVC model view controller. View is whatever the user sees, the graphical elements, the table. You see in the name of the class, it was table view and list view. So these are the views. And then there is the controller in this classical model. It's the logic between, it decides what kind of updates should the model have when the user interacts with the interface, and how the view should be updated when the data model changes. This is a classic model. It has existed for several decades, and it's often mentioned, but it's actually very rarely implemented as a pure model like this. And Most important thing is that you have the basic understanding of what the model view controller is and what are these three parts, the model, the view, and the controller. The model and view are usually there and can be easily identified, but the controller, the logic tends to be blended into one or two, or all of them blend together more or less. But it's also important to understand that the model view controller architecture can be found in different levels and different implementations, and this can even exist in the same system. So in a low-level component, you have, for example, what we had here, we have the table view as the view, and we have the observable list as the model. And then basically the controller can be found in those event handlers and callbacks, which define how to convert the data to the view and how to update the data when the user clicks a button or does something. In the medium level, the application itself can have one big model where all the data that the user is operating on is modeled as some sort of an object, and it can be listened to, and the entire interface, visual part of the interface, can be considered the view, and then the controller. At this point, it might be useful to try to put all the controller, the logic in one place or not. That's, I believe, why the model view controller as a pure architecture is not so common, is that putting all this logic into one controller component tends to not actually make things more clear, but just artificially separating it from where it would be more natural to write. And in client-server systems, you can find architectures where, for example, the model is in the server side and the client side, like what is in the web browser running, that's view part, and then controller is one or another or combination of the two. So, as you probably understood, I'm not recommending that you aim for the model view controller without hesitation and forcing it everywhere, but it's important to have at least an idea of what model view controller is, because you will probably see and have probably seen this model and mentions to it in different various sources. And I think that was my last summary slide for this. Well, let me check this next slide. So, because I did have this, I used this slide from last year, so collections framework and diamond notation. So some of my code option menus from time, but I used the Java util list in this examples. I will update this slide before I put it into the Moodle. Java util list, for example, is part of this collections framework, which is in Java util package. And yeah, there are list and map and many other data structures part of that collection or that framework. And this diamond notation or generics is used there systematically, so you can, for the list, tell that, okay, this list contains this kind of objects. And yeah, that makes code easier to read, because when you do this, the compiler knows that, okay, this list will only contain these three labels, for example, so you can directly add them there. When you get something out of there, they are the JLabel type of things. And yeah, on the definition level, you can see that there is this generic is. If you go look at the specification, you often see this list E, for example, extends collection E. This is the generic type, which is then, this E is replaced by, for example, this JLabel when you do this. And yeah, this helps compiler to know what data types go into this structure and what data types come out of that structure. So using these generics and this diamond notation is recommended whenever you receive a class which supports it. For example, this Java util list. If you are not yet familiar with this, I definitely recommend you to get to know. Okay, so I think this is the lecture for today. I will publish this lecture and these slides later today, and I will also publish the next set of exercises as soon as possible. I still have the wireframes to draw and prepare a little bit for the React track versions. Do we have any questions at this moment? Of course, now that we don't have the physical exercise sessions, I welcome communication through Moodle forums and also via email. So if you have trouble with the exercises or have any questions, just go ahead and contact me whatever way you find most useful. I try to be there even if I'm not physically there. Okay, thank you for your time. I will close this session now, and as said, be in touch when you need or want some help or support.